Hello future GATE achievers, welcome back to Shortcut. Today we are focusing on one of the most fundamental algorithms in the graph theory, that is breadth first search or BFS. Whether you are solving for shortest path, analyzing network flows or checking graph connectivity, BFS is a technique you will use time and time again. Let's dive in. Let's see what is breadth first search. Breadth first search is a graph traversal algorithm that starts from a chosen node, explore its neighbor before moving to the next level of neighbors, and continue level by level. This makes BFS ideal for finding the shortest path in unweighted graphs. Now, BFS works by using a queue to explore a graph level by level. It flows these steps. Start at a selected node, means source node. Mark the node as visited and enqueue it. Dequeue a node, explore all its unvisited neighbors and enqueue them. Repeat this process until all nodes are visited. Let's consider a simple graph. Start at A. Mark it as visited and enqueue it. Then dequeue A and visit its child means B and C and enqueue them. Then dequeue B, then visit D and enqueue D. Then dequeue C, visit E and enqueue E. Continue this process until all nodes are visited. BFS is widely used for several purposes, means finding the shortest path in unweighted graph, label order traversal in trees, checking connectivity in the network, solving puzzle like finding the shortest path. Now see the time complexity. The time complexity of BFS is order of V plus E, where V is the number of vertices, means nodes, and E is the number of edges. BFS visits each vertex and edges exactly once, making it efficient even for large graphs. Here, a basic implementation of BFS. This code starts at a node, enqueue its neighbor, and prints the traversal order of the graph. BFS is useful in several real-world scenarios, means social network analysis, web, GPS navigations, etc. These practical uses makes BFS a crucial algorithm in both theoretical and practical computing. I hope this deep dive into BFS helped you understand its importance in graph theory. Here's how you can keep learning. Like this video if it clarified BFS for you. Subscribe to ShortGate for more GATE preparation content. Comment below if you have questions or requests for topics. In the next video, we will explore depth first search, means DFS, and compare it with BFS. Mastering these traversal algorithms is key to solving many graph-based problems in GATE. Thanks for watching today's session on BFS. Keep practicing and apply BFS to different graph problems, and you will see how versatile this algorithm really is. Stay tuned for the next video on DFS, and until then, happy learning. Let's crack GATE together.